Hello everyone, a very good morning to all of you, dear authors and invited guests. A very warm welcome to technical session 10C. So myself Yashita, and I'll be your moderator for this session. I'll make sure that everything runs smoothly. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, which is ICTIS 2026. So, the 11th edition of the conference is being organized 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, while the virtual sessions are being conducted via Zoom from 9th to 11th April, where people from all over world are present with us. So I hope you enjoy today's insightful, knowledgeable and interactive sessions. So in this session, we will be having a total of 10 presentations. Each presenter will be given 10 minutes for presentation followed by 2 minutes for question and answers. So I will be giving a gentle reminder at the 9-minute mark to everyone just to help everyone stay on track. Also, small request to all the participants, stay connected with us till the closing remarks. So we promise it will be worth it. So if you have any queries or updates, feel free to drop them in the chat box anytime. Me and my co-host will address them anytime. So before we begin, I would like to introduce our esteemed session chair for today, Dr. Kalyan Devappa Bamne sir. He is an associate professor in Department of Information Technology at D.Y. Patil College of Engineering, Akurdi, Pune. With over 18 years of experience, he specializes in computer networks, cybersecurity, and distributed systems, and is a recognized PhD guide at Savitribai Phule Pune University, SPPU. So, sir, welcome to the session. And if you would like to give some welcome remarks for today.
Thank you, Ishita. Am I audible?
Yes, sir, you're audible.
Yeah. It's very nice to have you in the particular session. Thank you very much for inviting me, and all the best for all the participants for the presentation. Over to you, Ishita.
Okay, so for the first presentation, we have with us Amit Kalita. Are you present in the meeting, Amit? Let me check once. Okay, I think he's not present. So next we have Shankar Lingam. So Shankar, are you present? I think he's also not present. Nagesh Sharma, are you present? Okay. Mehak?
Yes, ma'am, I'm present.
Okay, so Mehak is here to present her paper titled as Alopa, an AI-powered lightweight on-device private assistant. So Mehak, are you ready with the presentation?
Yes, ma'am, I'll have to share the screen.
Yes, yes, I'll stop sharing. Yes.
Okay, ma'am, just a second.
Yeah. Are you sharing the screen, Mehak? Yeah.
Hello, ma'am, is it visible?
Yes, it is visible. You can start.
Okay.
Okay, so complete the presentation. I request all the participants here who are going to present that complete it in 9 minutes, 8 to 9 minutes, so that the whole session will finish on time. Okay, so yeah, you can start.
Okay, ma'am. Good morning, everyone. I'm Mehak Agrawal, and I'm here to present our work, Alopa, an AI-powered lightweight on-device private assistant. Many of the existing artificial intelligence based assistants are cloud dependent and require constant internet connectivity. The user data is sent to the external servers for processing. While the data is often encrypted, but it is prone to risks. Many of the existing on device solutions have high computational requirements and require a complex technical setup, which makes it difficult for people from a non technical background to use them. Through our work, we present a completely offline and on device, lightweight AI assistant that ensures complete data privacy. It can work on a limited RAM, eliminating the need for high end devices. Moving on to the highlights of our proposed system. So one of the major highlight of our proposed system is that it can function completely on device and offline on a limited RAM. It is completely hands free to use because the user does not have to uh, manually enter their query. They just have to speak their query. The system is activated by a wake word, and the user can select among different wake words which are customized to the Indian context. Am I audible, ma'am? Okay.
Yes,
Yes,
you're
you are
audible.
audible.
You're clearly audible. You can go ahead.
Okay, ma'am.
Yeah.
Yeah, so I was saying that there are different wake words available for the users to select from, and which are customized to the Indian context. It also allows users to ask document as well as image related queries to the system. It is completely open source and has cross device and cross operating system compatibility. It allows the users to select among various on device LLMs to generate response to the user query. So this table shows a comparison between the existing cloud dependent on device systems and our proposed system. It shows that our proposed system does not require internet. It can answer the document related queries, and it has low setup complexity. It is open source and is multimodal. So moving on to the working of our proposed system. So a lightweight, low-power wake word engine sits at the top of the system. Only when it detects the wake word, the rest of the system gets activated. So after the wake word detection, the voice-based user query is converted into text using the speech-to-text engine. This text is then sent to the on-device LLM along with some additional context. So the model output that is generated, that is cleaned up and is formatted for the visual clarity and displayed on the screen. Simultaneously, a text-to-speech engine provides the voice output. It also allows users to capture an image and ask queries based on the image. So we have created both mobile-based system as well as desktop-based system. So the mobile-based system is built on the Flutter framework utilizing a business logic component architecture. It uses a lightweight TF-Lite microspeech wake word engine for the wake word detection. And for offline speech-to-text conversion, Sherpa Onyx has been utilized. For the offline text-to-speech conversion, native Android TTS is utilized using the Flutter TTS library. Moving on to the desktop-based system, it utilizes a Python-based backend with the Flask framework. It uses the library OpenWakeWord for the wake word detection. For offline speech-to-text conversion, Whisper has been used as it transcribes on-device, ensuring full privacy. It also utilizes Piper TTS for on-device text-to-speech conversion, as it provides a low latency and human-like voice response. So the proposed system was tested with several data sets to evaluate the closed form question answering, mathematical reasoning, truthfulness, contextual understanding, named entity recognition. And it was integrated with different LLMs, including Gemma 3 1B, Phi 2, Quen 2 1.5B, Tiny Llama 1.1B, and Small LM 1.7B. To evaluate the closed form question answering, the test split of the ArcEasy subset of AI2 reasoning challenge dataset was used, which consists of the grade school science questions in a multiple choice format having 4 options. So the selected option was compared against the ground truth to calculate the closed form question answering accuracy. For mathematical reasoning, the GSM 8K test split of it was used. And the system was instructed to provide a numeric final answer, and that was compared with the ground truth provided in the dataset. To evaluate the truthfulness of the system, binary questions from strategy QA dataset were used. And for this evaluation, the response was considered truthful if it either matched with the correct answer or if the model expressed uncertainty. To evaluate contextual understanding, the Squad 1.1 dataset was used. Each instance provided the system with a reading passage along with the question based on the passage, and the system was instructed to provide answer solely based on the passage. So for this evaluation, we used BERT score F1 because it compares the semantic similarity between the generated response and the actual answer, unlike the exact match metrics. So this that was used to find the quality of responses. The F1 score projects the semantic accuracy of the system. Further, to identify and classify the real world entities, the validation split of the CONLL 2003 dataset was used, and the system was instructed to classify them in the entities into four types of persons, organizations, locations, and miscellaneous. System generated entities were compared with the ground truth tags to using a relaxed string matching protocol to account for the minor formatting variations. So these are the results that we have obtained. High scores were obtained for closed form question answering, which showed that the system performed well with the multiple choice questions. Low scores were obtained for mathematical reasoning, which showed that it struggled with the multi step reasoning tasks. The system with Phi2 and Quen2 1.5V showed high scores for truthfulness. A higher truthfulness indicates lower hallucination tendency. Low scores were obtained for the contextual understanding, and superior results were obtained for the named entity recognition. Further, we have also evaluated the response time and the memory usage of the peak RAM usage of the system while it was integrated with different LLMs, including Gemma 3 1B and Quen 2.5 1.5B for desktop, Gemma 3 1B and Gemma 3 and E2B for mobile. So it was observed that the system struggled with heavier LLMs of like Gemma 3 and E2B, giving an average response time of 22 seconds. Furthermore, the system was tested for image-based query responses for two different on-device LLMs, including Gemma 3 4B and Lava 7B, which the system was asked to describe the image, and it was instructed to provide a concise response to it. So the satisfactory results were obtained as the responses for that in both the cases. So, our future work includes adding multilingual support to the system, improving the contextual understanding, and conducting user testing to determine the usability and user satisfaction with the proposed system. So, the source code that was used in this work is publicly available at these links. So, yeah, that's all from my side. Thank you.
Okay, sir, any questions from her?
Yeah.
Also, we have to make this session as interactive as possible. So, anybody from the participants has any questions, they are welcome to ask the questions. Over to sir if you have any questions.
Yeah. Mehak, can you go up to the objective for this particular research? Yeah. In between, I would like to ask that ki whatever the models you had been worked on, that worked on the GPU, right?
GPU we've used for desktop-based system. We have created for the mobile device as well.
Okay, then how mobile devices we had worked on? What would be the backends for the same?
Like we have tested it on device having a 6 GB RAM, 128 GB internal storage, and with a powered by a Qualcomm Snapdragon processor 750G.
So are they giving proper results, accuracy?
For accuracy, yeah, they are giving. Only thing is that the response time was a bit problem with the heavier LLMs.
Yeah, that is the only reason. See, we
Yeah.
are moving towards the AI, AI domains. So We should look into that matter because everybody, there are a number of smart users, right?
Yeah.
Smartphone users now. It should be handy one now, so you look into that matter to increase the response time. So what would be the requirement, accordingly you work on.
Yeah,
That is
sir.
one. Second, how many algorithms you have gone through?
Like for the wake word detection, we have trained the model to develop the particular wake word for its detection, and for text to speech, we have used it differently. And
So for TTS, are you taking existing model, or you are just again you are preparing your model also for TTS?
for TTS, we are using the existing model. So the Piper TTS, as I mentioned, that was used for that.
Okay, and what is the accuracy of this?
For the text to speech thing,
Yeah.
so we are yet to do that as of yet. We only measure selected the LLMs and everything and the multimodal thing for the model.
And as you mentioned, question answering, you're getting good. That model gives you good accuracy.
Yeah.
Yeah, what type of questions are there?
There's a factual questions having they have to select from the options given. It is having four options, and they have to select it from that itself.
Right. And what about this optimizations? Compared to the existing one, as you have mentioned, there is no any requirement of internet, and how it would be possible then? So you need to have a large data set, right?
And I didn't get you, sir. What?
You have mentioned that your model did not require any internet facility, right?
Yes, sir. It functions offline and on device. Yeah.
Right. So you need to have a large data set in that case. Then how you are going to collect it?
So we are using a pre-trained LLM for that, for generating the responses and for providing the users data. They'll be uploading their documents if they want to ask questions related to their personal data, since it is on device and it will ensure privacy as well.
Could you please justify multimodal input?
Yeah, so we have like it can user can capture the image and then they can enter the query whatever they have to ask related to the image. For example, describe the image, and then it is being clicked and is the query along with the image is sent to the on-device multimodal LLM, which is like Gemma 3.4b or Lava 7b, and then the responses would be obtained related to that as per the question given by the user.
Okay,
Yeah,
fine. Thank you very much. Over to you, Ashika.
thank you, sir.
Thank you so much, Mehak, for presenting. So, next presenter is. Yes, so up next we are having Samya Ali to present her work titled as Data Availability and Uptime in Cloud Storage, Redundancy Models and Storage Techniques. So, Samya, are you ready with the presentation?
Yes, I am ready.
Yes, so you can start
Just a second.
presenting. Yes.
Is my screen visible?
Yes, it is visible. You can start.
Okay. So, good morning, everyone. I hope you're all doing well. I'm Samyali from Bayer University, and today I will be presenting a research on data availability and uptime in cloud storage, redundancy models, and storage techniques. So, our work focuses on improving reliability and efficiency in modern cloud storage systems. So, as we all know, cloud storage is the backbone of modern digital infrastructure, supporting applications across industries. However, ensuring continuous data availability and system uptime is challenging due to hardware failures, network issues, system outages, etc. etc. So, the key problem we address is how can we maximize availability while minimizing the cost and still managing performance. So, I would like to define a few key terms before moving forward. Data availability refers to ensuring that data is always accessible whenever required. Uptime represents the duration for which the system remains operational, and redundancy is a technique of storing additional copies or encoded data to prevent data loss. So, there are several redundancy models used in cloud storage systems. In our research paper, we have worked on 5 of them, being replication, erasure coding, rate-based, multi-cloud redundancy, and hybrid models. Replication is the model that creates multiple full copies of data, providing fast recovery but at a very high storage cost. Second one is erasure coding, which splits data into fragments with parity, which makes it storage efficient but also computationally expensive. Third one being the rate-based approaches, which provide disk level redundancy but are limited in large scale distributed systems. Fourth, multi cloud redundancy, which distributes data across multiple providers to improve fault tolerance but increases complexity and latency. Then we have hybrid models, which combine replication and erasure coding to balance cost, performance, and reliability. So these are 5 methodologies that we have used, C1 to C5. C1 being replication only, C2 erasure coding only, C3 hybrid model, C4 RAID-like hybrid, and most importantly, C5 adaptive hybrid model. The key contribution of our research is C5, that is the adaptive hybrid model. It dynamically adjusts redundancy strategies based on system conditions such as workload and failure patterns. So the result of our hello, am I audible?
Yes, you're audible,
Yeah, yeah,
Sam.
yeah.
Okay. So the result of our research is that the C5 model uses continuous monitoring and a decision-making system to choose between replication and erasure coding dynamically. For frequently accessed data, it may use replication to ensure low latency, and for less critical data, it may switch to erasure coding to optimize storage efficiency. This also allows the system to balance cost, performance, and availability in real time. Our analysis show that adaptive hybrid model C5 performs the best among all the other models. It achieves approximately 99.99 availability while maintaining lower cost and reduced latency compared to static approaches. This makes it highly suitable for modern large-scale cloud environments. As a conclusion, replication provides high performance but is expensive. Erasure coding is storage efficient but introduces latency and complexity. Hybrid approaches improve the balance, but the adaptive hybrid model C5 emerges as the most effective solution as it dynamically optimizes redundancy strategies. This makes it ideal for meeting strict service level requirements in cloud systems. As for the real world impact and future scope of our research, this research is highly relevant for real world cloud platforms such as AWS, Azure, and Google because they have to maintain high availability while optimizing cost. And as for the future work, this model can be enhanced using AI based prediction techniques for smarter redundancy decisions and can be implemented in real world cloud systems for validation. Thank you so much for your time and attention, and I would be happy to take any questions.
Samit, just show me your title of the research.
Sure.
Right. Now, you have mentioned here redundancy model and storage techniques, right?
Yes.
Now, everyone we are running behind the cloud. So, how you can say that we are more removing the redundancy 100%? Are you claiming accordingly with
Sorry,
the
sir, can you
hybrid
repeat?
model? As you have mentioned, hybrid model, how much exactly accuracy they are giving?
99.99%.
Right. So, had you worked on practically to get that?
No, sir, this is actually a theoretical research. We have still not worked practically for it.
Okay. Is that research is just only a survey-based research?
Yes, sir.
Okay. So, as per the literature survey, could you please tell me 99.99% accuracy they have received? What were the algorithms? What exactly the steps they had been processed?
Sorry, sir, you're not clear.
What are the steps they had been followed? Rather, whatever the authors they had worked on, right?
Yes, sir.
Literature survey. So, let me ask you
Yes, sir.
exactly what are the different authors propose different things and which one is the best knowledgeable things they had been adapted through this data redundancy. Rather, redundancy model is one. And see,
Yes,
let
sir.
me tell you one thing. Over the cloud, it's not possible. Redundancy would not be possible, right? Because
Yes, sir.
everybody's perception is different. So uptown also one of the thing, you know. So your data availability and uptime, that is one thing. For that, you are just having redundancy model and storage techniques. So redundancy model, as you have mentioned, you are going for the hybrid model, right?
Yes, sir. Sorry.
C5 and storage techniques also you are mentioning. So how these are related with each other? Could you please elaborate more on it?
Okay, sir. So the 99.99% availability you're asking about. Hmm. So
Yeah,
that was
yeah.
achieved. Yeah, that was achieved by combining multiple redundancy strategies. So we compared between five strategies, and we thought that replication and erasure coding was the best. So we thought of making a hybrid model for it, and that was achieved by combining the first one, that is the replication. So in which data is replicated across multiple nodes or regions to ensure immediate access during failures. And erasure
So what
coding,
was
that is,
what was the time complexity, cost complexities for the same if you are having the integration of these models? Had you worked on it?
so actually this is
In
only a literature based research and not a
okay.
practical one.
Even though it is literature based, though somebody has been being implemented individually model as well, right? So
Yes,
every
sir.
model.
That can actually be vary depending on the redundancy model used.
No, no, that's
Like
what I wanted
replication,
to
it
ask
has,
you. But then
yeah,
why you have shifted to the hybrid model? That is what my question.
because that balances both. Like it dynamically selects the best optimal strategy, and then it works on both replication and erasure coding dynamically,
Okay.
and
Okay,
it gives
fine.
efficient performance with optimized cost. That's why we have used hybrid model.
Okay, fine. Thank you.
Thank you so much.
So thank you so much, Soumya. So, our next presenter is Roshni Tawade. Are you there in the meeting? Okay, she's not there in the meeting. Gunjan, she is also not there probably. No one. So I think we will have to wait more 5 to 10 minutes for more participants to join us, and then we can start again. So this might be because of Saturday or something that no one is here. Let's see, we'll wait for 5 to 10 minutes. Is it okay for
Okay.
you, sir?
Yeah, yeah, it's
Yeah.
okay. Total time, I will also take 10-minute break if it possible, and then
Yes,
I'll
yes,
join
sure.
back, right?
Yes, sure.
Yeah, thank you.
Yeah.
I'll be there in the meeting only, don't worry.
Yes, yes, sure, sir. Okay, so we'll move forward to the next presentation as we have one participant with us, which is Taslima Supti, sorry. So, Taslima, are you ready?
Yes, ma'am.
Yes, so you can start with your presentation.
Okay, I'm going to share my screen. Please
Yes,
tell me if it's visible and audible. Okay.
yes, yes.
I think it's saying if someone is presenting, I cannot present
I
my
have
screen.
already stopped my sharing. You can try once again.
Okay, ma'am.
Yeah.
I hope my screen is visible.
Yes, it is visible. You can start.
Okay. Assalamu alaikum. Good morning. My name is Taslima Firdaus Shukti, and I am going to present our work titled as a two-stage explainable framework for infant cry classification with RL-based feature fusion. The table of contents are as follows: introduction and motivation, problem statement and research gap, proposed methodology, dataset and pre-processing, model architecture and feature fusion, explainability with SHAP, experimental result and analysis, computational efficiency and robustness, and then conclusion. So starting off, an infant who cannot talk, his only way of communication is crying, and we need to understand the reason, decode the signal of their crying, and their crying may indicate hunger, pain, any sort of discomfort, comfort, etc. And if we can decode their signals properly, it can also help to diagnose early diagnosis of neurological disorders or respiratory distress syndrome, etc. So the problem here is it is completely difficult to manually detect problems from their crying audio signals. And there is also environmental noise interference. And as we have reviewed some work related to our work, we have seen they have, although they have many better accuracy or nice accuracy, they have problems like class imbalance in their data sets that they have not taken care of sophisticatedly. And then they did not incorporate interpretability. And then there was their systems were computationally expensive. So in our work we have created a two-step hierarchical classification, so that in noisy environment we do not get false alarms and be concerned. And we have used adaptive feature fusion, and there was SHAP for interpretability, and of course there was reinforcement learning for the adaptive purpose, and it give better weight on important parameters. And also since ours is not computationally expensive, it is not resource hungry, so it is efficient. Yeah, and it can also be used in real time. In our dataset, it is we got our dataset from infant cry Kaggle, and it is named as infant cry dataset. It has a total 889 samples, where 565 samples are cry samples, and the rest are non-cry samples. And cry subcategories are then also classified, and the subcategories are belly pain, burping, etc. And non-cry may not cry may mean laugh, noise, external environmental noise, etc. In our methodology, the methodology works like if we put an input and audio, the pre-processing is done, and since there is class imbalance, we have used data augmentation method. And then in stage 1 it is a binary classification phase, so cry, not cry is detected in this phase. And if only cry is detected, it is then multiple types of features like cepstral, prosodic, and qualitative features are extracted and then put into the feature fusion method, where RL is used. And there is put the every feature is put another different weights according to by using reinforcement learning and interpretability. And then and in stage 2, the sub classification is done, why the crying is happening, and the output is the cry intent, why the baby is crying or the infant is crying. And then there is also SHAP explainability to show us the importance of the feature, and also there is an model explanation as well. For data processing, in the data augmentation phase, we used time scaling to create tempo variation, pitch shift, because of anatomical variation in infants crying. And also we injected noise so that it is robust in real world scenario. And for class balancing we used SMOT. There are three types of features: cepstral, prosodic, and qualitative, and their corresponding ones are mentioned. In the RL based feature fusion, gamma is the discount factor, and we have used 0.9, and R is the reward, which is the accuracy of current batch classification. Sorry about that. Sorry, I'm back. And reward is negatively correlated with frequency of a given level in a given class, so that the agent maximizes the frequency of features that assist in identifying infrequent but important labels. There is explainability of so that every feature that is connected importantly connected or connected to corresponding cause is backtracked or known, what is causing what, to know what is causing was what. And we have used a lightweight deep neural network, and it is used in the final classification, and the dropout rate is 0.3. We used ReLU activation, and for optimizer we used Atom optimizer. And there is also kernel SHAP for explainability, and for evaluation we did macro F1, we used macro F1 score. In stage 1, we can see that the F1 score is of binary classification. Cry-not cry classification is 0.53 and 0.47, but the confusion matrix shows that the system is effective in filtering high energy household noises. And in the ablation study, we can see that if we only consider cepstral features, the F1 score is 0.78, and if we use prosodic features, the F1 score is 0.655, but in the proposed the system we have proposed, the fused one, it has a F1 score of 0.92, and the convergence rate is here we can see that the agent converged to approximately 200 epochs and was able to learn to place more weight on features that recognize rare high stakes levels. And computational efficiency, we did some parameter reduction via kernel pruning, and the compression was really, if it went from 5120 to 1280, and the ratio is 4, but since the compression ratio is 4, but less than 5% accuracy loss was there, so it may mean that although we did a trade-off, but the model will be will work on low resource hardware, but the latency will still be minimal. And impact of additive noise, we can see that the noise is up to 5 decibel, the accuracy drops smoothly, but only when the noise is very high, 0 decibel, then the accuracy is 72.4%. And we have said that we have incorporate the SHAP importance feature, the SHAP that will show the important features, and here are the top four most important features: MFCC1, pitch average, energy RMS, and chroma 3. And in conclusion, we can say that since it is a hierarchical model, the first stage is used to clear confusion. If it is noise, then we're not concerned, and which helps in real world application. And since there is a reinforcement learning, the feature fusion is gets better, and also there is explainability in our work, and since the system we created is efficient enough, so it is Yeah, it can be used in real time with low resource. Thank you so much, and that's all from me.
Actually, I would like to ask that real time, what would be the efficient parameters for the same?
Yes, sorry.
Is it implemented one? Is research is implemented by yourself or is it just survey?
Yes, it is implemented, but it is not used in real time yet.
Okay. If it would be useful in the real time, then what are the different domains we can go for?
What? Sorry, I'm sorry. There is a mic going on outside. What is that?
Am I audible now?
Yes, sir. There is noise in my area. I'm sorry about that.
Okay. Fine, no worries. If this research is implemented, as you mentioned,
Yes, sir.
if you apply this research in the real time, what are the different domains we can go for to implement it, to utilize it, and what are the different parameters we can say that on the basis of this my research is fruitful.
Okay, so the domain you're asking is it can be uh, definitely the audio ones.
I mean to say that you have implemented the research, so looking into the matter of where it could be applicable in the real time, that is very much important, right?
Oh, it can be applicable in households, and it can be applicable in the hospitals where infants are kept. Does it answer your question?
Yeah. And what are the different algorithms? Had you used the existing algorithms, or you have implemented your own algorithm over here?
The feature fusion part here is done with our convention, and the algorithms use deep neural network and sorts are the ones that is already there. I don't know if it answers the question.
Okay. What are the performance factors? On the basis of this, we can say that our research is optimized one.
Because we have kernel pruning.
Hello.
Yes,
Am
due
I
to
audible?
kernel pruning. Yes, sir. Due to kernel pruning, I mean, we have pruned parameters up to pruning yeah, is 4. Compression ratio is 4. So it is that is why it is efficient, I guess
Okay.
so. Yes, sir.
Okay. Thank you.
Thank you, sir. Should I leave, ma'am?
Yeah, you can wait till the closing remarks if you wish to.
But I think I have work, so um, is it
It
mandatory for me?
no, it is totally up to you.
Oh, thank you, ma'am. I would like to leave. Assalamu alaikum.
Okay, thank you. So I think we are done with the presentations for today as nobody else is present. So we have come to the end of the session, and I sincerely
Hello, ma'am.
thank
I'm
all.
present.
Actually, I announced you earlier. Your paper is not in this session, I guess. You are Roshni Tawade, right?
Lovely. Yes, yes.
Okay. So, but the visual was different. So, fine then. You can start presenting.
Okay, ma'am. So my paper was in this session or another session?
You are Roshni Tawade, right?
Lovely. Yes, yes.
Yes, so it is in this session, so you can start.
Okay.
Yeah. I announced you
Let
earlier,
me.
but that there was no response from your side.
No, no. Due to my mic was not working, so that's why.
Okay, so you can start now. No issues.
Yes, thank you. I'm sharing my screen.
Yes.
My screen is visible now.
No, it is not yet visible. Try to reshare, please.
Okay.
Roshni, is it happening?
Now it will my. Now the screen is visible now.
No, it's just a black screen. The Yes, now it is visible. You can start.
Now it is visible.
Yes, you can start
Okay.
quickly. Yeah.
Okay. Thank you for confirmation. Good
Yeah.
afternoon, one and all present here. I am Roshni Tambe, and today I am presenting my work on helmet and number plate detection using YOLO V8 mode. This is my paper ID 519, and paper title will be helmet and number plate detection system. These are the flow like abstract, problem statement, problem definition, introduction, theory, proposed methodology, important findings, result and discussion, research outcomes, conclusion, acknowledgement, and reference. First is abstract. So traffic rules enforcement is essential for road safety, but manual monitoring is inefficient and not scalable. So to address this, we propose an automated system using YOLO V8 model for object detection. The system dataset, sorry, the system detects helmet violation and number plate. It supports multimodal like image, video, and live streams. It is evaluated using precision, recall, and map. So the model performance is training accuracy will be 88% and the validation accuracy will be 79%. Now this is a problem statement. Manual monitoring is labor intensive and cannot handle large scale traffic efficiently. So it is difficult to ensure continuous surveillance. So the objective of this work is to automatically detect helmet violation and identify number plate and enable real-time traffic monitoring to improve road safety. So the introduction is road accidents are increasing due to helmet violation, especially in urban areas where motorcyclists are widely used. So the traditional monitoring methods are inefficient. So there is a need for an automated system. So that's why come into the picture. Deep learning techniques like YOLO V8 enables accurate and real-time detection, making them suitable for intelligent traffic surveillance. Next slide will be theory part. The system is based on deep learning and computer vision using YOLO V8 architecture. So the YOLO V8 consists of three main components. Like first one is a backbone, second is neck, and third one is head. So the backbone which extract features from images, and the neck is which combines features at different scales, and the head which predicts bounding box and class levels. The key features of YOLO V8 is single stage detection. Next one is real-time performance, and next one is high detection accuracy and multi-scale object detection. This is a YOLO V8 model architecture. Here you can see backbone, neck, head. These are the main components in the YOLO V8 model architecture. This model I have used. This is a proposed system. Here you can see this diagram shows the overall overflow of the systems. So the first we take the input data set containing image of vehicles, then process the applied including resizing and normalization. And then next YOLO model is trained on the data set. The trained model performs detection and classification of helmet and number plate detection. And then finally, the system produce output with bounding boxes on images, videos, and real-time webcams. Next one is proposed methodology. Here you can see the prediction classification will be detect helmet usage, identify number plate, testing data used for model validation, and output will be detect on result on image, video, real-time webcam. Like important findings will be, our findings shows that the YOLO V8 provide fast and accurate detection. The system effectively detects helmet usage and number plate and perform well under different traffic conditions, making it suitable for real-time applications like helmet, without helmet, number plate. It will detect. This is the result and discussion. Here you can see evaluation metrics. I have used precision, recall, and MAP 50. This is with helmet precision 0.90 and recall will be 0.64 and the MAP 15 will be 0.76. Without helmet will be 0.80 and the recall will be 0.80 and the MAP 15 will be 0.90. For number plate will be precision will be 0.92 and for recall 0.81 and for MAP 50 will be 0.90. It will provide the high accuracy for real-time performance. This is a result of, actually I had made it, like this is without helmet, it will 0.80% and this is number plate 0.77 accuracy. And for with helmet will be 0.89 accuracy and the number plate 0.80. Previous is for image only and this is for live traffic video feed. Here you can see that it will detect in a live video, like with helmet or without helmet. And this is an actual live video based detection helmet violation. Here you can see it is live, like without helmet it's 0.32 and with helmet will be 0.30. This is a research outcome. The research result is in the development of the automated detection systems, and it reduces manual effort, provide real-time monitoring, and support images, videos, and live streams. This system is scalable for smart city traffic management system. In conclusion, the proposed system is efficient and accurate for detecting helmet violation and number plate. It improves traffic rule enforcement and enhance road safety. In future step, the system can be extended by integrating OCR for number plate recognition, deploying on cloud platform, and integration with smart traffic systems. I would like to thank the Department of Technology, Hyderabad Philip University, for providing the necessary resources and environment. I also acknowledge the use of YOLO V8 by ultra analytics and open source resources that contribute to this research. And I would like to thank the organization of ICTIS Thailand 2026 providing this platform to present my work. These are the references. Thank you for your time and attention. I am happy to answer any questions.
Yes. First of all, it is very good topic, and
Thank
for
you,
the
sir.
PhD purpose, it is also definitely very good. Now, there are two, 3 points I would like to talk about.
Okay, sir.
Uh, this helmet wearing is compulsory, right, in the
Yes,
metropolitan
sir.
cities. Okay.
Yes, sir.
Now, 80% people, they are not at all accepted to wear the helmet.
Yes.
So, is there any reason, and that reason would be satisfied through your research? Through research, could you be able to give any message to them? That is one thing. Second thing is about the technical aspects. The real time results, I have seen that these are pretty good results, right? So, let me ask you that what are the different algorithms you had applied for this? Whether these are the existing ones or you have been implemented one, what is that exactly?
Like existing one I have used.
Okay. So existing algorithm, you might have been, gone for the, different types of parameters execution. Like we can say that this algorithm is good for accuracy, this is good for the optimization, this is good for space-time complexities, like that. So existing algorithm, what are the already implemented part? What are the already implemented parameters, and when you had used this in your research, then what would be the optimized one?
Yes, sir. Like I have used YOLO B8 model by using that it can predict the like image, video, and live stream.
Yeah, that is what model you are talking. Is there no any algorithm is being used?
Uh,
There is no any need of any algorithm to be used, or what? How you have done the
yes,
classification?
yes, sir.
How
I
you
have
have
done
done
the
the
class.
classification?
Acha, okay. How you done the classification? Like
Or you have
like
directly
training.
taken the real-time image or what? And you have just given to the model, and accordingly model has just to satisfy to that ki whether the person is with the helmet or without the helmet, and how the the calculation should be obtained over there with the helmet, without the helmet. There back end side you might have been implemented something, right? What is that? I hope am I audible to you?
Yes, yes, you're audible, sir.
See, you are showing that with helmet, without helmet, the parameters it is been obtained, right?
Yes, yes.
So back end side some mechanism you had been applied over there. What is that?
Yes, sir. Like I have used libraries like TensorFlow and OpenCV, and
Okay.
also I have used the Flash. Flash is used as a, backend web framework to handle requests, run the model, and communicate between the user interface and the detection system. Like it will communicate between the my model and the interface, user interface.
Okay. So how much accuracy you have received for this compared to the existing
Like for
models?
yes, sir. Like training, 88%, and validation, I am getting 79%.
Okay. And you have mentioned that real time you have already been implement, you took the test cases in the real time as well, right?
Yes, yes, yes.
So how many test cases you have gone for?
Like for with helmet and without helmet,
Yeah. But
and for
how
and
many
also
tests, how many users rather? I mean to say, test case should be applied. So only one test case, we cannot say that ki my research is fruitful, right? So you might
Yes.
have been gone for different type of users, then collected approach. Then it could be mentioned that ki research gives you that much accuracy. Research gives me optimization like this. I mean to say.
Yes, ma'am. Like according to like Ultra Analytics, it has used by over 5 millions of users.
No, not according to XYZ. I want through your research.
Okay,
This is your
according to my
PhD
research.
topic, right?
Yes, 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 sir.
See, my concern is how many users you are asked for this. Utilize use this helmet, wear it. Like
Yes, yes,
suppose 10 users you ask for,
yes, yes. For my
and how
teachers
do you
and my colleagues. Yes, yes, my colleagues as.
right? How many then? 10, 15, 20.
Okay, you can take like 10.
So 10 members. Had you taken the average of all the with helmet, without the helmet, and had you compared between them? Is there any change? Means whether the difference is going to be constant
Yes,
or
sir,
it is
depending
going to
upon.
vary.
Yes, sir, depending upon the angle and
Okay.
yes, depending upon the angle, the result will be changes, and depending upon the like lighting, weather, this is also
Well,
changing the result.
thank you very much.
Okay, thank you so much.
Okay, thank you so much, Roshni, for your presentation. So next
Thank
we
you.
have Gunjan Parekh with us. So Gunjan, are you ready?
Yes, ma'am, I'm ready.
Yes, so you can start presenting.
Yes, ma'am.
Yes, so just a reminder, Gunjan, you have to complete your presentation within 8 to 9 minutes. Gunjan, you are not audible to us. You're on mute.
Yashita, is it audible to you, this presentation?
No, no,
Because
no,
it's
it
not
is
audible.
not. Yeah, it is not audible for me
Now,
as well.
now,
Yes,
ma'am, I'm still audible.
yes, you are audible. Now you can start.
Okay. Good morning, everyone. Respected faculty members, I'm Gunjan Parekh, a research scholar at Vanasli Vidyapeeth. Today, I'm presenting my research work on objective evaluation of transfer learning model for the multimodal human activity recognition. So, these are the outline of my presentation: introduction, related work, proposed methodology, result analysis on the wisdom dataset, and the PEM2 dataset also. Same data reading, data pre-processing, feature visualization, comparative analysis. After that, result analysis, conclusion is here, references. So now the introduction part, I'm starting with the introduction part. Human activity recognition is a research area that focuses on identifying classifying the human activities in many fields like healthcare, smart homes, and the fitness monitoring, etc. So the major problem in HR is to handle the complex and diverse data, that is multimodal data set. So I'm working on that. This research, this research mainly focus on to study to evaluate the transfer learning models such as VGG 16, ResNet 50, Netsnet 121, MobileNet V2, EfficientNet B0 on the multimodal wisdom data and PAM2 dataset to identifying the best performing architecture among all for classifying the 18 human activities, because these data set contains 18 human activities. So the table 1 shows the existing related work of HAR. So now I'm starting with the proposed methodology. Here's the complete pipeline of my proposed work. First of all, we are using the multi-model dataset, that is Wisdom and PAM2 dataset, wireless sensor data mining and physical activity monitoring. These both are a multi-model dataset, means it contains the data from multiple modalities. So after that, we have taken the pre-processing step. These are some series of steps we have taken: standard scalar, label encoding, and 20 frame wise reshape. So in standard scalar, we have used the standard scalar because to normalize all the features, so on all the features are coming on the same scale. Then label encoding is done, same as activity labels are encoded to the numeric label. And last one is 20 frame wise reshape, means in that because all the data is time series signal, so we have to convert this time series signal into the 2D image by the GAF transformation, Gramian angular field transformation, with the summation method. So in this 20 consecutive frames we have taken, and that converts into the two-dimensional two-dimensional images, so that easily it can be processed by the CNN architectures that I have told you earlier. So then after that, the models are trained like VGC16, ResNet 50, MobileNet V2, DenseNet 121, EfficientNet B0 are trained after training. That goes to the testing part, and these are the evaluation matrices like accuracy, precision, recall, and F1 score. So now the result analysis on the wisdom dataset is here. This is the data load of wisdom dataset. Wisdom dataset is basically contains the data from both the smartphone and smartwatches, and like phone accelerometer data is here in figure A, B gyroscope, watch accelerometer, and watch gyroscope data in D part. Now the result analysis of the after the pre-processing data. The pre-processing data, the figure shows the data pre-processing after the standard scalar as it is shown in this slide. Next, the feature visualization is there. Is a sample GF image of the wisdom data set after the GF transformation of all of the 18 activity classes. Now, result analysis of wisdom dataset, that is comparative analysis. Table 2 shows the uh, shows the summary of the performance of model that are trained on the same parameters like ADAM optimizer 50 epochs, learning rate 1 e minus 4, 0.001, that is early stopping patience is equals to 5. So as we conclude that like DenseNet 121, ResNet 50 achieve the highest performance on all of the matrices like accuracy, precision, recall, and F1 score. And same like VGG 16 and MobileNet V2 is also performing optimal performance on all of the matrices, but EfficientNet B0 performs very poor, like 7 to 11%. So this, as shown in bar chart, completely shows on bar chart in table 3, model wise accuracy comparison of the wisdom dataset. So now I'm starting with the PAM2 dataset. This dataset result analysis of the PAM2 dataset. This is a data load. In data load, this is basically a sample dataset. Now the data after the pre-processing, we are getting this type of data, that is standard scalar data after pre-processing. Next, the feature visualization here is here in figure 8. This is the sample GF image of the PAM2 dataset that is shown in this figure for each of the activity classes like walking, cycling, jogging, etc. Now the table 4 shows also the comparative analysis of all of these models, and they are also trained on the same parameters: ADAM optimizer 50 epochs, learning rate 1 e minus 4, early stopping patience equals to 5, and we clearly visible sees that ResNet 50 and DenseNet 121 achieves the greatest performance, superior performance among all. And EfficientNet B0 is also performed good in PAM2 dataset, but VGG16 perform very lower. MobileNet V2 achieves optimal performance, that is model wise accuracy comparison on the PAM2 dataset is here. Now the conclusion is that in conclusion, my opinion is that the sorry please. So the wisdom and I'm testing the data on the wisdom and PAM2 dataset and demonstrated that the choice of the deep learning architecture strongly affect the human active recognition performance. And on the wisdom dataset, DenseNet 121 and ResNet 50 achieved the highest performance with 99% accuracy, precision recall, F1 score, and same for the PAM2 dataset. So overall, the DenseNet 121 and ResNet 50 is stands out the effective and scalable model for the complex sensor-based activity recognition, and also MobileNet V2 achieved good performance. It is lightweight architecture for the real world application. That's all from my side. Thank you. Any questions, please?
Yeah.
Yes, please.
What you motivated the use of gap over the signals?
Because sir, gap converts the time series signal into the 2D metrics, and that is helpful because time series signals are very low graded signal that is to convert into the 2D matrix so that they can be processed by the CNN. So time series signals easily perform on uh, sorry, deep learning architecture. So that's why.
Are there any class-wise performance variations among the 18 activities of it?
Sorry, I'm not getting you, sir.
You had mentioned 18 activities in that, no,
Yes,
results.
yes, sir. Yes, sir.
So are there any class-wise performance variations?
Yes, sir. Each activity has class-wise variations.
Okay. Then what are the key limitations of your proposed framework?
Sir, this is only the objective now.
Hmm.
So limitations. This is only the study now.
Okay. Can this framework will be extended to healthcare or anomaly detection applications like?
Sir, they are helpful for the smart homes also and physical activities because they all these data set are works these data set basically on the physical activities like the person is walking, jogging, etc.
Right, right. So can the model support real-time deployment on wearable
Yes,
devices?
but MobileNet V2, sir, because this is a lightweight model.
And why do DenseNet 121
Hmm.
and ResNet 50 outperform this other architecture in this particular case?
They outperforms very good because sir, DenseNet 121 can also take the data from the previous layers also, and ResNet 50 is also use the skip connections. So basically, they are strong models.
Okay.
Yeah.
And what would be the future improvements to be envisioned behind the gap and CNN model?
So the future improvements is that they are deployed in real time scenes.
And when it would be noisy environment in the real time, then how you does your
So
approach be?
sir, this is the future scope of our model.
Okay. Well, fine. Thank you.
Thank you, sir.
Okay,
Thanks a lot.
thank you so much, Gunjan, for your presentation.
Thank you, ma'am.
So, next we have with us Mahzooza Afreen to present her work titled as An Explainable AI Driven Framework for Movie Recommendation Systems Using Big Data Analytics. So, Mahzooza, are you there in the meeting?
Yes, ma'am. Here. Can I present my screen?
Yes, you can present your screen. Just a humble request to each participant, please complete your presentation within 8 to 9 minutes.
Okay, ma'am.
Yes.
Ma'am, can you see my screen?
Yes, but the presentation is not visible.
Okay, ma'am.
Like the meeting is visible. Yeah.
Now,
No, the files are visible.
ma'am, can you give me some moment? Actually, I think my network has been corrupted.
Okay, so you can quickly fix the issue. Till then, I'll check with other participants
Yes, ma'am.
if any of them
Thank
are
you so much.
available. Yeah. Okay, I can see Rajeshri Das Chetty in the meeting. You are here to present your paper.
Ma'am,
Ma'am,
my
I'm
network has
from Mahajuja's team.
You are from?
Mahajuja Friends.
Okay.
Ma'am, my network has been fixed. Can I share?
Yes, you can try to reshare. Yeah, it is visible.
Okay. Good morning, everyone. My name is Mazuza Fin. Today, I'm presenting our research named an explainable AI-driven framework for movie recommendation system using big data analytics. My co-authors are Rajashri Das Choiti, Gaji Tahsina Sharmin Jahin, Mosharf Hossain, and Mohammad Shamsul Arifin. These are the overview. At first introduction, in the modern digital era, the rapid growth of platforms like Netflix and Amazon Prime has made a movie recommender system essential for helping users navigate massive amount of content. Um, these systems use big data to suggest films based on specific user interest. However, there are three core issues: popularity bias. Um, Ma'am, would you, can you see the slides?
Yes, but the slides are not moving. It is still on the title slide. You can start the slideshow and then it will happen.
Ma'am, I indeed start the slideshow.
Like from beginning, yeah.
Now,
No, it is not happening. So
so
your co-author can present and you can talk or something like that.
yes, ma'am. Is it possible?
Yes, it is totally possible.
Okay, I'm presenting now.
Yes, you can start. I think you guys should resolve your issue. Till then, I will continue with the next presentation.
Yes, ma'am.
Yes, so Devang Darvi, we have Devang Darvi with us.
Oh, yes, ma'am.
Yes, so you can start presenting.
Okay.
Yeah. So he is here to present his paper titled as Prompt Engineering Beyond Techniques for Large Language Models Across Domain Review. So you can share your screen and start.
Yes, ma'am. Is my screen visible?
Yeah, wait. Yes, now
Okay,
it is
yes.
visible.
So, good morning. My name is Devang Dalvi, and I'm presenting my paper title, which is Prompt Engineering Beyond Techniques for Large Language Model Across Domain Review. First of all, I'm very honored that I'm presenting my paper at ICTIS 2026. So the introduction, in this paper, we offer a specialized review of a prompt engineering for a centric viewpoint with a large node of contextual development. And we also show like how the prompts are very much useful for LLM models to generate a response. Because if a proper structure prompt we are using for an LLM model. So proper expectations output will be received by an LLM model. The paper also attempts to establish the construct of information of prompt engineering via real-life examples applications. So we have also used 4 to 5 use cases as a real-life example, like how prompts can deploy it on LLM model by giving the proper response as an output. The paper will also introduce the deficiencies in prompt engineering in realism of reproducibility, robustness, and the unavailability of standardized approach in the aspect of concrete evaluation. So before understanding the use cases, like how prompts are actually being used for any LLM model, the architecture diagram, which I will explain you right now. So first, in the architecture diagram, as we use in a daily life, we as a user, we write a prompt for any LLM model. So the model can be anything, a GPT model, a Claude model, a Gemini model, any model. So what we do is we first write a proper structure prompt. That proper structure prompt has been given to an LLM model. And then on that LLM model understands the structure prompt, and on that basis, it produces output. Now, why LLM produce output? Because it has been trained on a billions of parameters. The LLM, which stands for large language model, has been trained on a large data set. It is a corpus textual data set, and that data set understands the model and helps to guide the LLM to get a proper response. For example, if I'm writing something as a prompt, a well-structured prompt, if I wrote, and I will feed that prompt to the LLM model. So in the architecture diagram, you can see that the pre-trained on billion of parameters. So how LLM model understands the prompt, it guides through it, and that LLM model has been trained on a large data set of a corpus, and on that basis, it provides you the output. So if a prompt is proper, the LLM will understand the prompt, because prompt will guide LLM that what we are expecting from LLM model has an output. So well-structured and precisely designed prompts are critical while writing a prompt and while giving to the LLM model. So the first use case which we have used is an image generation of an AI engineer using Gemini 2.5 Flash image. So over here, what happens? Sorry. Over here, what happens is if an image generation refinement, now you can see two images are there. So left image and right image, both the image contains an AI engineer who is working on his desk setup at home, where there is a three screens and is working on some neural networks. So image generation refinement, a structure prompt was used to generate a photorealistic software developer who is actually working on his desk setup. So now in the left image, what we have given is that we want a dark theme for an AI engineer who is working on three screens. And then the Gemini 2.5 Flash image generated that photorealistic with high accuracy image. After that, we did another research like how a generated image can also be used for different types of images. So we used that generated image, we gave that image to the LLM model, and after that, we did use some different types of prompts, like some changes for dark theme to light theme, and the cables, the cups which are there on the desk setup should be clearly visible. So both the examples were generated by the LLM model, which was a Gemini 2.5 Flash image, which is a multi-model model. So role of prompt engineering model capability, the experiment demonstrated that well-structured and precise design prompts are critical for generating high-quality domain-specific image, providing the multi-model LLM like Gemini 2.5 Flash image, it interpreting complex visual instructions. So if a prompt is well structured, then LLM model will understand that prompt and it will generate the best outcome which will match to your expectations. Another image, another example of an image, which was my image, where I've given that and as an example to the Gemini model. And I told him to generate a specific AI engineer who is working on his desk setup on some neural networks, and a small pop-up tag should be there on his image desk. So as a result, it matched my expectations as an output. Why? Because my prompt was clear and well structured, which guided the AI to focus details and accuracy. The better performance reduced robustness and produced more relevant results. And prompt precision unlock model powers where AI performance like Gemini 2.5 Flash image improves the significant well designed because of the prompt. The second use case was prompt engineering interaction architecture with APIs. Now, as a software developer, we do use APIs for predictions or for classification of any API key. So over here in this interaction architecture with API, we did use an NLP progress. So we did use Wikipedia API. So the code utilized the Wikipedia to retrieve summary of a topic title known as natural language processing. So what exactly happens? We have used Open API model of GPT 4.0 Mini. The code uses this Open AI model to understand and to augmentate the information to Wikipedia. So first we did use paper title, which was natural language processing. Then that natural language processing was retrieved from Wikipedia API. So the entire information regarding each and everything of natural language processing was retrieved. Using Open API model, we did give a proper prompt. Can you please provide a question explanation of natural language processing? So by giving this prompt, it augmented the information from that Wikipedia API, which was retrieved before. And in an example of this displetion of output, it generated an example of natural language processing. So over here, the basic thing is that if a proper prompt was given to the model of Open API, and from that model, it augmented the retrieved information and it displayed as an output. Another use case was performing the architecture diagram. Now, as a student, as an employee, we do use architecture diagram for our presentations, for our assignments, and for daily use case. So over here, we did use Claude AI model and also Gemini model for creating the architecture diagram.
Devang, sorry to interrupt. You have to wrap it up in next 2 to 3 minutes.
Sure, ma'am.
Yeah.
So as you can see, there are two images, which images for prompt engineering in healthcare and smart campus resource booking system. So both of the images were generated by AI through prompt, where a proper description of a project was given to the AI. A well-structured description of the project was given with a better understanding of the project, and on that basis, it generated the image of architecture diagram. So within a second, AI actually generated the architecture diagram, which takes a lot of time for us to do it manually. So it was very time consuming to generate the architecture diagram. Before understanding the use cases, there are some of the project techniques of prompt engineering: zero-shot prompting, few-shot prompting, chain of thoughts, and instruction rule based. So in zero-shot prompting, the model generates a response without any example. So you just don't have to give any example, you just have to give a proper prompt, and on that basis, model gives you the output. In few-shot prompting, the model is provided with a few examples before the actual task to guide. So there are some examples which have been given to the AI to get the proper output. In chain of thoughts, the model encourages things step by step. It understands this step and it helps to reasoning the model. And in instruction and rule-based prompting, a proper instruction has been given to the model using prompt. Advantage is it improves the model performance without retraining by writing the prompts. It helps by guiding step by steps. It helps the model to perform very well. It is cost effective and time efficiency. It's flexible and adaptability across tasks. Disadvantage is that lack of productivity, it limited robustness, and sometimes it cannot be used while there is no internet programmability for any prompt to use on LLM. In conclusion, the paper highlights the importance of prompt engineering by focusing on contextual understanding and practical impacts on the use cases. It identifies the key challenges such as lack of robotics, robustness, and standard evaluation methods in prompt engineering. Thank you.
Well, Devak, let me ask you. You claim
Yes.
performance improvement, right?
Yes.
Can you show me raw before after the outputs how you have been taken care of the comparison between these two?
Images.
Yeah.
Yeah, so first we generated the image from Gemini AI. So the left
Mm.
image which has a darker tone, which was generated by the Gemini AI model.
So that is the practical approach by your methodologies, right?
Yes, exactly.
Right.
But after
So
that, it helped the model to generate the refinement evaluation. Why? Because we gave
what
that
is that ratio is? What is that accuracy is exactly?
the accuracy depends on the second image. Like we have given that image to the AI model, and we have also experimented on that particular image to change it into a light mode. So the image was basically in dark mode, so it converted into light mode. So the accuracy was about 90 to 95%.
If what would happen if your
Okay.
prompt is slightly modified?
Okay.
Do your claims still stand for the same as implemented?
No, if a prompt is modified, so it won't give you the acceptation output that you require. For light mode, if you add a prompt which is modified, so you won't get the better example response such as this right image. So the output would be different if your prompt is modified.
What exactly if your prompt versions and iterations led to your final results?
Basically, we have to write a proper prompt for the final results. If a prompt is very structured and the proper instruction has been given to that prompt, so LLM understands what exactly you want from an output. Basically, prompt guides LLM model prompt guides LLM model to get a proper response back, and LLM understands what we actually expecting from him based on the prompt. So if a prompt is perfectly evaluated and well written, on that basis, LLM will give you an output.
What are the specific sections of the ideas which are entirely of your own and which are adapted from the existing literature of the research papers rather?
So the literature review research paper, we have adapted that how the models can be trained on different data set using prompts. Like sometimes we do use AI models for getting the data set. Nowadays, we do use Cloud AI to get the data set. For that, we do write a proper prompts. The prompts which we are evaluated, sometimes what happens is like we give an example of a proper prompt, so LLM understands, and on that basis, it gives you an output as a data. Second, for architecture diagrams, we do use instruction-based prompting, which we have understood from a literature review. Like a proper instruction has been given, like you are an architecture assistant and you have to create an architecture diagram for the following description, and the description which will include the project description. Sometimes
As per your okay, fine, thank you. As per your opinion, where your approach fails completely?
The approach fails completely when the output has been generated through an LLM model. What we actually do is that we just give the proper prompt. The structure prompt is actually required for any LLM model to generate an output. So our expectations failed when output has been created. For any task, such as for generating and visualization of a dashboard through Cloud AI, so you can just give a proper description of your data set. You will feed a data set to the LLM model. You will give a proper prompt of a description data set, and then he will generate an output of a visualization dashboard within no seconds. So the expectations heads on the output that you received from an LLM model.
So overall performance, as per your opinion, how much percentage you would rate there? 99% I have completed, maybe 10% remaining. What is your opinion
In
as
my
per this?
opinion, for this use case, my opinion for the accuracy, what I would say is that it is 98% completed and 2% is remaining. Because
So in future you are going to complete 2% also, then what would be the efforts you should put behind that to complete 2%?
The first would be like now as you can see in the second image, the it is showing the lighter version of a theme. Okay, but
Right.
sometimes what happens, we also need some capability, some realistic photos of a particular person sitting on desktop. Now you can see in that a person is sitting, but sometimes what happens, both the images are looking similar. I want that second image should look little different as compared to the first image. So the realistic part is missing something that actually should be recovered.
Okay, well, Devang, thank you very much. Over to you, Yashita.
Thank you.
Yes, sir. Thank you so much, Devang, for your presentation. So, Mazuza, is your issue resolved?
Yes, ma'am.
Yes, so you can try resharing again.
Okay.
Yes, go ahead.
Good morning, everyone. My name is Mazuza Fin, and today I'm presenting our research titled "An Explainable AI-driven framework for for movie recommendation system using big data analysis." I have also my co-authors. Next overview. Um, Here are the overview. At first, introduction. In the modern digital era, the rapid growth of platforms like Netflix and Amazon Prime has made movie recommender system essential for helping users navigate massive amount of content. However, three core issues remain prevalent. Popularity bias, a lack of transparency in how algorithms operate, and the challenge of scaling this system to handle millions of users effectively. Next motivation. We have our motivation for this study is threefold. The long tail bias. Most systems focus on popular mainstream item, ignoring exceptional but less known long tail movies. Lack of transparency. Users often don't understand why a movie is recommended, leading to accountability concern. And the last one is scalability. Um, the many existing models behave like black boxes and struggle to process massive dataset efficiently. For this, we use fair recommendation, explainability, and scalable solution. And now literature review. There are many authors that we take inspiration from them, but we here we present three of the authors. At first, um, Wang Yiwu et al. In 2018 proposed a Spark-based framework using sentiment analysis, while Newly et al. Have demonstrated the effectiveness of the ALS algorithm for the scalable collaborative filtering. We also looked at explainable AI implementation like Sharp and Lime, which have been used to increase user trust and transparency. Next, are research objective. Here are our goals of our framework are to improve the ALS-based recommendation model to be more scalable, address long-tail bias by enhancing exposure for low-frequency item, integrate Sharp to provide clear explanation for recommendation, evaluate performance using RMSE and fairness metrics on a massive scale. Here are the methodology overview. Data generation. At first, dataset generation, HDF storage, preprocessing, dataset splitting, ALS model, sharp expansion, and evaluation. Now I'm going to the slide data generation. Here there are we use a distributed synthetic dataset containing 10 million interactions from nearly 1 million users. The dataset includes 15 attributes such as ratings, watch time, user ID, budget, lead actor, actress name, etc. To ensure the reliability, we intentionally added data perturbation and missing values to simulate real-world messy data. Now, HDFS storage. For processing, we utilize Apache Spark running on HDFS with an Apache Parquet format. The platform we use named Kali, where block size is 128 and replication factors is 1. And now the pre-processing step. Our methodology begin with data cleaning, where missing numerical data estimate using median of mediums algorithm, and dummy variable are used to fill the categorical gaps. Our Then we use our most important part, which is shielding detection. We identified that 2.1% of users were anomalous, giving high ratings despite very low watch time. Removing this user result high fidelity dataset of 9.73 million interaction. Then we split the 80% training and 20% testing dataset. Now, ALS models we use here. The core engine is ALS model, which maps users and movies to to a 10-dimensional latent feature vectors. Key parameters are optimization, least square optimization, already fixing users item vectors, regularization. A term of lambda equals to 0.1 was used to prevent overfitting. The scale, here you can see in the image, the scale, this generated approximately 978,604 user vectors and 99,999 movies vector. Here, next we will go to slide the explainable AI with Sharp. To overcome the black box problem, we applied Sharp. Since Sharp cannot be applied directly to ALS, we create a surrogate regression model trained on ALS prediction. This allows us to visualize how features like watch time, budget, actor influence the final recommendation score. Now I'm going to the slide of result analysis. Mm, Here we can see the two table. At first, that time we use for data loading, pre-processing. Here we can see that our proposed model takes too much time for to generate result. We compare our proposed model with AS baseline, which is normal model. We didn't use any pre-processing steps like shilling detection, etc. And second table, we can see that the our proposed model outperforms as less baseline, where RMSC perform better, which is 1.84 compared to the baseline. Furthermore, precision 10 can improve from 0.74 to 0.78. Our long tail exposure reached to 0.79. It confirms that our framework is better at surfacing the diverse, high quality content while maintaining accuracy. Now, for the XI insights, where we can see that watch time has a upper hand. Um, there are also top five along with watch time, which is movie name, user age, user ID, hero name. Now the conclusion. In conclusion, we have developed a scalable, transparent framework that successfully combines big data processing with explainable AI to provide fair movie suggestion, while our model has a higher execution time due to complexity. Now limitation and future work. Um, we can see that our model has high execution time due to its complexity. The gain its fairness and accuracy are substantial. Further research we will explore additional fairness dimensions such as regional and group based filtering. Thank you for your attention. Any questions?
Yes. You mentioned you removed 2.1% of users. How did this impact overall model performance?
Actually, sir, can you again mention the question, sir?
It's a part of data reduction. If data will be removed, if it would be, it would say 2.1% of users. How did this impact overall model performance?
Yes, it impacts actually because um, that time we take when the fake user gave the fake review, it shows more time. But when we remove that, it shows not that times, but it's indeed higher than the normal ALS baseline that time.
So, is your anomaly detection method validated against standard techniques?
Um, Sir, yes, it's a validate against standard techniques. Actually, I performs different techniques uh, for uh, for the uh, actually I performs different techniques for this topic.
How does your system handle evolving user behavior over time to time?
Sorry, sir.
How does your system handle evolving users' behavior over time? So
Uh,
behavior aspects here.
Behavior. um,
Okay, did you analyze whether imputation introduce any bias or data distortion?
Yes, sir. Actually, I analyze the data distortion. Um, because I use, sir. I at first I say that I use synthetic data where I add the missing values. Like, can you go to the slide of the data set? Here I add the some missing values, you can see, because the real world data has some lack of the problems of missing values. So I add this and solve these problems so that I can show you that.
Okay. Why did you use dummy variables here instead of other encoding techniques?
Sir, sir, actually, there are other techniques but I think only to these things, to this techniques like these are common techniques. But at future, in future, I will apply many more techniques.
Last question. As per your opinion, what would be the exact criteria to define an anomalous user in your system? What do you
Mm,
mean to say? What would be the definition of anomalous user?
for anomalous user.
Right. Well,
Sir, actually, for anomalous user, we um,
no problem. Last question. How do you ensure that the genuinity of the user, okay, who are not incorrectly removed, means we used to say false positives.
yes, sir. Sir, actually, false. I use shielding detection where we can see that our fake users are removed. I didn't use any metrics where we can see that false positive or false negative. I used only shielding detection to remove the fake users.
Okay, well, over to you, Ashita. Thank you very much.
Okay, thank you so much, Mazuza, for your presentation. So next we have a co-author of Amit Kalita. On behalf of Amit Kalita, Abhijit Chakraborty will be presenting the paper titled as A Decision-Oriented Evaluation of Self-Supervised Learning for Chest X-ray Pneumonia Classification. So Abhijit, are you ready with the presentation?
Yes, ma'am.
Yes, so you can start sharing the screen. Yeah, you can share now.
Am I audible?
Yes. So I request everybody to please complete their presentations within 8 to 9 minutes strictly because we are already short on time and there are few more presentations to go. So please cooperate everybody. So Abhijit,
Okay.
you can start.
Good morning, everyone. My name is Abhijit Chakravarti, and I am the author of this test paper. And today I am going to present our paper, which is basically a decision-oriented evaluation of a self-supervised learning for test exam pneumonia classification. Coming to the slide, basically detecting the pneumonia from the test is very much critical for the clinical diagnostic. And most of the existing deep learning models that is basically rely on the supervised learning and evaluate based on the accuracy and the ROC AUC curve. So, however, this metric does not reflect the real clinical decision making. So, in this work, we has compared self-supervised learning with the supervised learning model under the same similar condition. So, our results showed that self-supervised learning provides a more balanced and a reliable process. So, coming to a slide. So, these are the few points that I am going to discuss, like the introduction, then the literature review terms, the methodology, results, discussion, and some limitation of our paper. So, in the introduction, like pneumonia is one of the major causes in the worldwide for the death. So, to detect the disease pneumonia, so chest X-ray is one of the useful tools, diagnostic tool that is mainly used because it is much more affordable. But the main challenges is that it requires the expert interpretation and high variation between the different radiology real-time decision making. So to overcome these challenges, so the AI can be used to improve its consistency and to improve its performance more better. But the model that is present currently, its evaluation is very much limited. So the problem statement from this we have taken, like the most of the existing approaches use the supervised learning with a large level data set. So where they report like they have a high accuracy and the good ROC curve. But this metric does not show us the how that model will behave in the real decision scenario when there is an imbalanced data set. So we consider the problem that high accuracy will not mean that it will provide a reliable decision making uh, for the data. So because it may consider all the false positive cases also in this accuracy, which will be very much risky in the medical sector. So the research are the two main research gaps still what we have research now. So first one, the evaluation is mostly based on the aggregate metric like ROC and the AUC, or so we can say based on the accuracy. And the second is that limited focus on the decision reliability and the false positive behavior, how they behave in it physically. And the literature review, like we have kind data CNN based model, the ChestNet, which is basically the high accuracy and which are fully supervised. Then currently we have the transfer learning ImageNet, which improve its performance and require the level data. And now we are having the self-supervised learning, which basically learn on the unlabeled data and use this contextual learning for learning the various data set. So what we have thought that instead of proposing a new model, let us focus on the evaluation. So we compare the self-supervised written model with the supervised model we trained from the test. Then we have trained both the at the same the identical condition so that the fair comparison can be done. Then our main contribution on this work is that first we have a control comparison between the SSL and the supervised learning. Then we have introduced the precision recall analysis for decision evaluation. Then we showed the SSL provide more balanced prediction. And fourthly, that we use the explainable AI to understand that how the model is being taking the how the model is reading the data. So with the help of the grayscale visualization technique, then we come to the data set. So we basically use the test X-ray pneumonia data set, so which is publicly available in the uh, source and which basically use the medical imaging data set containing all the X-ray images for the pneumonia and the normal gases. And these data sets are in not in the similar pattern way. So it is divided into like training set and validation set and test set. Where you can we can see it in the table like there are different set training set we have made with training set we keep the few amount of validation set and the test set. These are basically our data set which we have taken. Then I'm coming to the methodology side. Like We have the data people with normally the model which required for the model training. Then we have the SSL pre-training, that is self-supervised training we have done. Then for linear evaluation for that self-supervised training. Then we have the same for the supervised baseline training also we have done with from the stress. Then we have evaluatory performance and the metric that we collected, that is the accuracy, the recall, control and the ROC ability curve to identify what is be the evaluation accuracy or what will be the our evaluation of this model. So coming to next slide, this is SSL filtering. Basically, we have considered the unlabeled data and generated the image, augmented image pair. And its main objective was to learn the similar representation for the same image. And the model is taken as a ResNet 18. And disadvantage is that no independent on the level. So, and the supervised baseline also, we have trained from the test and used the level data and same architecture we have used so that fair comparison can be done. That is the ResNet 18. And after this, the result what we have scored, like you can see that two models, like one is the supervised and the SSL T10 model we have taken. Like we have calculated the accuracy, precision, recall, FM4, IoT accuracy, AUC. So here we can see that ROC AUC analysis of the supervised learning is much more than the SSL training model. But at the cost, when we look at the recall sector, that supervised learning basically provide the recall of 100% around, but the SSL provide 84%. But it when we compare it with the precision, that is basically balance between the precision and the recall sector for the association. But in the supervised, we can see that there is a huge difference in the precision and the recall. So that is the mean that supervised learning has a high recall, but there will be the various. It will calculate the various false positive cases. And the SSL part also, they provide a balance between precision and recall, which means that there will be the fewer false alarm section for the negative false positive case. So after that result, we have again done the ROC curve to identify. There we can see that the supervised model activates slightly. Mm, uh, can see that the supervised model activates slightly higher AUC.
Abhijit,
Uh,
just a reminder for you, you have to complete your presentation within 1 minute.
okay, sure.
Yeah, just
So
summarize everything, reach to the conclusion.
okay. So this is the IoT curve. We can see that supervised learning are basically receiving the overall high ability of can be defined between the phenomena, but phenomena and omega, but it only gives tell us how the it can separate the model. So it is not completely fair for evaluation. So we have done the precision for analysis. So here we can see that the supervised learning at after sometimes after a certain threshold, it basically drastically decreases significantly. But in the self-supervised learning, we have can see that there is a slight change and in the precision accuracy. So it basically balance between the precision and the recall set. So we have also done different basecamp analysis, which is basically the explainable AI technique, which we use to verify whether how the model is implemented from the basecamp visualization. So we have done where we can see that the SSL model is generally focusing on the large area, which is medically prepare for a civilian for the pneumatic system. Then from the discussion, we have observed that the supervised learning will affect the perfect recall section, meaning it depends all the mnemonic tests, but at the cost of the false positive detection. Whereas in the SSL model, it provides a balance precision, it provides a balance between the precision and the recall section. So it becomes a more reliable for the real world decision making process. So coming to the limitation, what in our page, that the results are basically based on the single base turn. So variation is not been analyzed, and then we have only used the one architecture, ResNet or one SSL method. Then we have the image. The third is the ImageNet pretend model, where it's not been included to maintain the control comparison. And the finally, the get them analyze only the quantitative and the not the qualitative and validated. So this limited will provide us for the future work, direction to the future work. And the conclusion in this, this work only present the decision-oriented evaluation of the self-supervised learning. while we can observe the supervised learning slightly have a higher accuracy at the cost of false positive, but in this SSL pre-training, we have the balance between the prediction and the between the precision and the recall sector. And then so from this only we can take that evaluation model only not only only basically on the traditional metric is not only essential. That means I want to say that based on the traditional metric, it is not sufficient for the medical sector. We should also based on look into the evaluation model sector also. So thank you.
Well,
Any
how does self-supervised learning compare to supervised learning for improving clinically pneumonia detection from chest X-ray images?
yes. Basically, we are keeping the same model, just the self-supervised learning processes which been done, and and the supervised basic way of doing the supervised learning process has been done, and both the results has been compared and been shown out. Have
How
taking all
does
the
the feature, are there any differences in robustness to noise or data imbalance between the two approaches?
we have considered all the factors in the same category.
Okay, how sensitive are both models to limited level data availability?
Once again, sir.
Then what would be the model's ability to generalize and to unseen chest X-ray data? How do you evaluate that?
Uh, So for currently we have just only evaluated the metrics related like the accuracy, precision, recall only. So there are some limitations for this, like we have showed only that um, we have to overcome with the multiple different model for that. Then only we can say that what will be the result
Can
for that.
self-supervised learning reduce bias or imbalance in medical image?
Self-supervised, yes, we can reduces the bias, but because self-supervised learn the that means the images with the help of unlabeled data. So it basically level its own data in the during the type of modeling only.
What extent ROCs reflect real clinical decision quality? How do you justify it?
Basically, I am saying that ROC, what we have to calculate, we compare the ROC characters. Basic, most of the approaches that is in the today's market, they basically show the accuracy in the ROC. But what we have seen that ROC only categorize the two classes different. It does not reflect the what will be the real time decision process. What will be a real time problem? It will calculate all the false positive cases also.
Okay, well, thank you.
Okay, thank you so much, Abhijit, for the presentation.
Thank you, sir. Thank you, ma'am.
Okay, so up next we are having Nagesh Sharma to present his work titled as Advances in Clone Attack Detection on Social Media Platforms, a comprehensive review of machine learning and deep learning approaches. So, Nagesh, are you ready?
Yes, ma'am.
Yes, so you can start presenting. Nagesh, can you share your screen?
Yes, 1 minute.
So, if not, you can resolve your issue. Till then, I'll take the next
Okay.
presentation. Okay, so Next, we have Miss Rashmi Vipat to present.
Ma'am, sorry to disturb you. My name is there, ma'am. Dr. M. Shankarlingam.
Yes, yes, you are there. I will be taking you. Wait for some time. So, we have Rashmi Vipat. Ma'am, are you ready?
Yeah, okay. Yes, I'm ready.
Yes, so she is here to present her paper titled as A Comprehensive Review of Machine Learning Based Crop Recommendation Systems Using Soil Quality Parameters. So, Rashmi, ma'am, you can start.
Okay.
Strictly, you have to complete your presentation within 6 to 7 minutes.
Yeah.
Just summarize. So, because the basic idea of these presentations are to that you have to present your idea. So, I think 5 to 6 minutes are okay with for that. So, you can start with it.
Okay.
Just like the abstract methodology and the result and analysis part. Okay. So, for everybody, it is the same. So, you can start, ma'am. Please share your screen fast. Yeah.
Is the screen visible?
Yes, it is visible.
Okay. Good morning, respected panel members. This is Rashmi Vipat, and I'm presenting the research paper titled Comprehensive Review. Second.
Ma'am, you are not audible.
Yes.
Yeah, yeah.
I'm presenting research paper titled Comprehensive Review of Machine Learning Based Crop Recommendation Systems Using Soil Quality Parameters. This paper basically, I'm currently registered as a research scholar in Atmi University, Rajkot, and I'm thankful, and I'm thankful for my for constantly motivating and guiding and support for to my guide, Dr. Priyank Doshi. So the paper basically is a literature review paper. It is basically covers agriculture plays a very important role in the development of any country, and for the economic development of our country. In agriculture, it faces like farmers are the main person, so they are facing multiple challenges. So the challenges which are faced by the farmers in the developing countries like us, and then what are the traditional crop selection methods, whatever they are using, they are inefficient for predicting the crop, and for selecting what type of crop should be is suitable for their farm soil quality, and then accordingly there is no mechanism using which they can predict the crop yield. So we have proposed a data driven approach like the ML techniques, and we can collect the data, and we can use the ML techniques to for crop recommendation and yield production. So the problem is the challenges faced by the farmers are lack of agricultural information, lack of information in on time, and accurate information is again not available. So if the historical data is available to the farmer, the previous data is available to the farmers for a specific soil quality which he has got at his farm. So accordingly, he can make some decisions regarding the selection of the crop, and when to irrigate, how much fertilizer is required, when the harvesting can be done, because there are again, another challenge faced by him is lack of limited soil knowledge is available. Like the soil which he has at his farm or at his land in order to test the soil quality, the cost which is required is much more, and similarly at the same time it requires time, and as well as if it is a remote place, remote area, rural area, then the facilities of lab soil testing is also very rarely available. So that is a limitation. Then another limitation is now today's scenario. Nowadays the scenario is like the weather and climatic conditions are very unpredictable. So and most of the Indian farmers are dependent on rain-fed farming. So if unpredictable rains happen, then he must have some pre intimation that something will be happening. So accordingly, he can take some precautions if it is in his hands. Then
Rashmi ma'am, I please request you to please move quickly to the methodology and then to the conclusion, because we have two more presentations in this session. Time we are short of time, so yeah.
Sorry, yeah. And it leads to poor selection, low productivity, and economic losses to the farmers. So machine learning plays important role in that. We can focus upon the soil quality parameters like NPK, pH, moisture, temperature, and uh, the factors accordingly. We can gather all the information and we can apply ML algorithms for that. So there are multiple smart farming technologies which are available, where we can gather data from IoT sensors and other multiple sources, and we can store it. We can integrate that data, we can apply algorithms, and we can provide the farmers can be provided some mobile apps for interacting with all these things, so that it enables the precision agriculture. So majorly the focus is on gathering all these data of soil, because all these are important for the growth of plant and everything. Then applying various algorithms. So there after literature review, these it has been observed that those literatures are using all these classification techniques of machine learning, and they are being applied for uh, various uh, various things in agriculture. So the proposed framework is integrate various types of data and apply, pre-process it, clean it, do the feature selection, and accordingly apply the classification technique, or we can also have some deep learning algorithms applicable, and we can do the recommendation of the crop, and we can do the production estimation once the crop is there in the field. So as per the weather data, as per the history data, as per the soil quality parameters, current soil quality parameters, production can be done, crop production estimation can be done. Accordingly, when to irrigate, then what fertilizers can be used or are recommended, and what quantity is recommended can also be estimated, and accordingly used by that information can be used by the farmer for better production of the crop. So along with it, the real-time monitoring via IoT sensors can also be done. So the basic framework is integrate the data, use ML models, and recommend the crop, and estimate the production, and at the same time use the real-time information for so that irrigation schedules and fertilizers scheduling can be done properly in and timely manner. The challenges which are faced are the data security and quality issues, lack of model generation, then real-time deployment. It becomes difficult because those things might not be available in remote places, limited accessibility by the farmers of all these things. and there can be like multiple future scopes available. So we have proposed that we can use machine learning techniques and some regression models for recommending crops and estimating the yield. But some deep learning models can also be used for advanced or to enhance the accuracy of that thing. And user-friendly mobile apps can also be developed so that farmers can monitor their farm easily in a user-friendly manner. So this is the conclusion that data integration can be done using various IoT cloud computing techniques, ML models, and then we can enhance the productivity of the crop, and suggestions can be given to the farmers accordingly. This is from my side. That is it from my side. Thank you.
Okay, so do you have any questions here?
Yeah. So let me ask you,
So,
for this literature, for going for the particular research, what exactly best paper you found out from which year?
actually, I have reviewed the around 29 to 30 research papers, and most of them are 20 to 22 onwards, but some of the papers are from the year 2020, and the papers which have been reviewed are some of the papers are from IEEE access papers, some of the papers are
No, no. My question is, what would be your best paper from which year? From where you got motivation to implement this type of idea?
actually I have the for last 5 to 7 years I've in our institute the conferences are happening which are domain specific, like medical or agricultural domain.
No, no, you're not getting my question. Okay, fine.
Uh,
How can the system ensure fairness and accessibility for small scale farmers?
so for small scale farmers, there is a challenge because the uh, the technology access is difficult in the remote places, as well as for small farmers they might not be using. So we have to make them aware that uh, this
What are the evaluation metrics you use behind accuracy to ensure reliability?
Sir, actually, I have just gone through all the literature, and I have understood that uh, that these are the classification techniques which have been majorly used for recommendation of the crops. So I have not actually uh, done anything. I have just reviewed the literature, and I have got these outcomes from those papers. Either
So, what are the then key challenges you have been identified for applying machine learning models to the real world farming environment?
the challenges are the information is not available. The quality, that whatever information or the data is available, the quality issues are there, and difficulty in implementing real-time deployment, like going to the a particular field and installing those sensors is a challenge, and making the farmers aware that they can the full system can work for positively for them is again a challenge.
Okay, over to you. Thank you.
Thank you.
Thank you, Rashmi ma'am, for your presentation. Nagesh sir, are you ready
Thank
to
you.
share your screen? Is the issue resolved? Okay, I think he's not in the meeting. So Shankar Lingam sir.
Yeah, very good morning, ma'am.
Yes, so he is here to present his work titled as a strategic framework for integrating ICT-driven intelligent systems into organizational decision making.
Yes,
So
madam.
you can share your screen.
Yeah, due to some technical issues, I'm unable to share my screen. I'll go through the presentation without my screen. Is it okay, ma'am?
Yes, sir, is it okay with you, Bhavne sir?
So this is very normal
No,
topic
but
actually.
presentation is very much important when you are having any conference, right?
Exactly. And yeah, yes, sir. Can I,
Without presentation,
yeah,
you
can
just
I,
send it to Yeshita. Yeshita, you can also play that from your side.
Yes,
actually,
yes, I can do that.
Yeah.
ma'am, can I upload the PDF, madam? Otherwise,
Yes, you are not able to share your screen at all.
one second, madam, one second.
Yes. You've
Yeah,
shared the
visible,
screen.
ma'am? Yeah,
Yeah, it is visible. The paper
yeah,
is visible.
yeah,
You
ma'am.
don't have a presentation?
Yeah, no, ma'am. Due to some other issues, we are
Okay, you
unable.
can go ahead. You can go ahead then.
Ma'am, actually, this is ICT-driven intelligent systems, and we are good in the preparation of agentic AI also. One of my scholars, they are working for agentic AI also. So the main intention of this paper representation is a strategic framework for integrating ICT, information communication technology, driven intelligent systems into organizational decision making. So whenever there is a decision making, when there is a support required, any kind of SWOT analysis, strengthening weaknesses, opportunity. So we can incorporate all the information into the particular applications. So it will decide. Elon Musk he already given some statement about the president of America. He said that after 10 years, no president is required to take a right decision, because if you are incorporating, if you are applying some kind of AI technologies, so it will give the latest trendy decision support system for population of USA or any country. So that is called agentic AI. So agentic AI means 85 to 90% of we are incorporating technologies, and 10 to 15% of human interaction. So they will it will give some innovative ideas to the globalization, whatever the things. So the main objective of this study to develop a comprehensive and a practical framework of organization, not only organizations, any sector, to adopt successful integration in intelligent system into their decision making process. Actually, every organization, every corporate sector, every business, they at any cost they want to take a right decision for better annual growth, annual performance. So the main intention of this research aims to bridge a gap between existing theoretical models and practical applications by proposing a step-by-step process that involves assessing organizational readiness, selecting appropriate systems, ensuring seamless integration. Same every day we have to update. See, because of non-updation of Android of that particular Nokia, so now the position of Nokia is almost dead, because now there is no updation, there is no technologies. Okay, now, so they denied for the Android. Okay, now, so in this case they have to take right decision before getting to the market actually. So I have taken the one kind of methodology that is employed includes qualitative case studies. We have taken the best case studies, best practices of all over India to diverse industries, supplemented with a review of relevant literature and theoretical models such as technological organization environment, that is called TOE, and one more framework from Fletcher in 1990. Based on the previously review of literature, we have identified some findings on successful ICT integration is contingent upon a well-planned strategic approach that aligns technological capabilities, and it promotes adaptive organizational culture actually. So we work the main intention of this paper is actually to decision making within organization traditionally, and it will reflect to the present scenario also. And the the main objective of review of literature we have taken from 2000 17 from to sometimes we have taken 1970 also, because of the development of decision support system, good in 1970s, 1980s also. And one second. This next is the challenges also in integrating ICT driven intelligent systems. That is organizational resistance is more important, technological incapability is important, data overload is more important, because of different authors, they have given some kind of research gap, that is called reluctance to adapt to new technologies due to fear of job displacement or lack of understanding. So we have all the database. So if you are we are using a DeepSeek or Grok or ChatGPT. So if you are incorporate some kind of all the information to put it into the application, so it will give the best decision support system to present scenario, present sales, because machine don't have feelings, they don't have. Simply they will understand the concept of the old literature review. Then it will give the best innovative ideas to the present scenario. Okay, now and second. Now I want to go to a conclusion part. This study presents a strategic framework for integrating ICT-driven intelligence system into organizational decision support system. The framework consists of 4 key components, that is organizational readiness, system design and selection, scalability, and alignment with the strategic goals. These elements are interdependent and provide holistic approach. Holistic approach is more important because the first importance of organizational readiness with evident in both the multinational corporation and as well as the selection of appropriate systems, whether of the shelf of customized design. And third, scalability is to adapt to all the technologies because of ICT driven intelligence system integration between the role of AI in decision making, AI ethics, ICT integration, long term impact assessment is more important to guidance to achieve strategic alignment of operational organizations. This is enough, madam.
Okay, well, what is the exactly importance of real-time data in decision making?
See, whenever you are taking a decision or any kind of any kind of decision support system, it should not affect to for your business or corporate sector anything, and it should not affect for any kind of employment also. Those kind of sometimes we have to adopt empathy is more important. Even the system, it will take without emotions, it will take decision. No, that is not recommendable. As a human being, we have to incorporate some kind of empathy is more important.
What metrics are used to evaluate the effectiveness of the system?
That actually one of my co-author is not available. Actually, he only 75% he only prepared the paper, and because of some technical issues, I only.
What are the stages involved for implementing the proposed framework?
Yeah, we have already discussed now, sir. Yeah, AI ethics, the role of AI decision making system is the
Then
first.
tell me, how do AI and machine learning contribute?
So in India, actually, now we are developing country. We are not 100% accurate to give 100% decision support system for any organization. Now we are working. And there are bias, there are botnets, there are different kind of ethical hacking system.
What are the
Ethical
risks
clearance.
of over-reliance? What are the risks of over-reliance and automated decision making? What are the different risks you identified?
No idea, sir.
Okay, fine. Over to you, Ishita.
Okay, thank you so much, Shankar, for your presentation. So, this was the last presentation for today, and we
Excuse
have
me.
come.
Excuse me.
Yes.
This is K. Shubham. Even I belongs to this itself.
Yes, but as we are short of time, 2 presentations will be taken in the next session, which will start at 10:45.
10:45. Oh.
Yes, it's the same link, so you can stay here. So we have come to the end of this session, and I sincerely thank all our authors for their excellent presentations and valuable contributions, and all the participants for being an important part of this international conference. I truly hope that this session, sorry. I truly hope that this session was insightful, engaging, and inspiring for everybody today. And on behalf of the entire team, we thank you for your continued support, not just for this 11th edition, but for all the previous 10 editions of ICTIS. We look forward to welcoming you again in the 12th version in 27. All presenters will be receiving the digital certificates through their emails within 2 working days. The publication will be live in 7 to 8 months approximately. So we kindly request your cooperation with the ICTIS team. And I would like to extend my sincere thanks to our session chair, Dr. Kalyan Bamne sir, for expertly chairing this session. So this is a small token of appreciation from the Team ICTIS and Global Knowledge Research Foundation and partners. So thank you all once again for your valuable presence. And before we officially wrap up this session, I request everybody to please turn on their camera so that we can capture this memory. So 1 second, I will click a snapshot. Yeah, so I request everybody, Nagesh sir, everybody please, yeah. Yeah, okay. Thank you so much. Thank you everyone for being present. Thank you so much, Bamne sir. Stay safe. Take care,
Thanks.
everybody.
Thank you very much, Ishita. Have
Yeah,
a great day.
yeah.